Okay, here I'm going to get my common denominator of 1 minus 2x and multiply both sides by that common denominator. Again, check for restrictions. Set it equal to 0. I'm going to subtract 1. Divide by negative 2. X cannot be 1/2. Back to my regular equation here. 1 minus 2x divided by 1 minus 2x is 1, which gives me x plus 2 on the left. On the right, I can't divide anything to simplify, so I distribute. 5 minus 10x. Here I want to get all of my variables together and all my number parts together. It's not quadratic, so I don't need to set it equal to 0. So I'm going to go ahead and just add 10x. Since I moved all my variables this way, I'm going to take and move my number parts the opposite way. Subtract 2. I have 11x equals 3. Divide by 11. And I get 3/11ths, which is approximately 0.27 repeating. I'm going to double check that answer. It's not one of our restrictions, so that seems fine. Plug it in. 3 over 11 plus 2 over 1 minus 2 times 3 over 11 should equal 5. My numerator, 3 over 11 plus 2, gives me 25 over 11. My denominator, I take 1 minus 2 times 3 over 11, gives me 5 over 11. And when I take 25 over 11 divided by 5 over 11, I get 5. 5 equals 5, which means our answer here is right. I'm going to hop back to example 2 here. You might want to have your books open to page 544 when we're doing this one. A flight across the U.S. takes longer east to west than it does west to east. Assume that winds are constant in the eastward direction. When flying westward, the headwind decreases the airplane's speed. When flying eastward, the tailwind increases its speed. So when we go east, we have the speed the plane is traveling plus the wind. When we go west, we have the speed the plane is traveling minus the wind, because the wind is pushing it back. There's that air resistance. The time for a round-trip flight from San Francisco to Chicago, which on page 544 shows you is 1,850 miles. So round-trip, it's 7.75 hours. If the airplane cruises along at 480 miles per hour, so that means the speed of the plane itself, like if it was to set cruise control, not how fast it's actually traveling. The wind is going to change the actual speed that it's going, but what it's set at is 480. And we want to know what is the speed of the wind. So a couple things here. We know it's a round trip, which means we're going to go there and back. And we know that those distances have to be the same. There was 1,850. We know the total time is 7.75 hours. And we know our dirt formula, distance equals rate times time. So since the thing that we have the total of is time, I'm going to go ahead and solve this equation for time by dividing by r. Because we're looking for we have the total time. So we're going to take our distance one way, divided by our rate, plus our distance back, divided by our rate, equals our total time. Again, distance divided by rate equals time. My rates, though, here, one of them is going to be my plane plus wind, and one of them is going to be my plane minus wind. In one direction, the wind is helping me. In one direction, the wind is slowing me down. Now I'm going to plug in some values because we know some things here. We know that our distance is 1,850 miles. And we know that our plane speed is 480 miles an hour. We also know we're looking for the wind. Okay, common denominator here. I have 480 plus W, 480 minus W, so I can mush those two together, multiply them to get my LCD. I'm going to go ahead and multiply everything by that common denominator. So I have 480 plus W, 480 minus W, and again we're doing this to every term. 480 plus W times 480 minus W, and 480 plus W times 480 minus W. Simplify what you can. 480 plus W cancels there, 480 minus W cancels there, and nothing on the right. I'm going to go ahead and just rewrite what I have right now, just to make it a little bit easier to look at. I have 480 minus W times 1850 plus 480 plus W times 1850 equals 750 times 480 plus W and 480 minus W. From here, I'm going to go ahead and simplify each side. I'm going to distribute on the left and FOIL on the right. So 1850 times 480, 8,888,000 minus 1850W plus 888,000 plus 850W, 775 times 480 times itself is 230,400. When I FOIL here, my outsides and insides are going to be the same, so I'm not even going to worry about them, and I'm just going to have minus W squared. I'm going to combine like terms. 1776000 minus plus give me 0. And over here I'm going to distribute 7.75 times 230,400 gives me 1785600 minus 7.75 W squared. Just distributed. Get my variable by itself by subtracting. And I get negative 9600 equals negative 7.75 W squared. Go ahead and divide by negative 7.75. And I get approximately 1238.71. I'm going to leave that on my calculator. I'm going to take the square root to get rid of the square. So I'm going to do second, exponent key, second, negative key brings up that last answer I had. And I'm going to get 35.195. I'm going to go 35.2 miles per hour is my wind speed. When we do square roots, we take plus or minus, but here we can't have a negative wind speed. So we're going with just the 35.2. So that's one way we can figure out what the speed of the wind is and how it impacts travel. Real quick recap. Solving an equation containing rational expressions begins by multiplying each side by the least common denominator of the rational expression. Doing this, however, can sometimes introduce extraneous solutions. Anytime that we introduce extra variables by like multiplying or squaring, things like that, we have to check for extraneous solutions. And there is your assignment.